Hello, my name is Kevin Pires. I am a Senior Applications Engineer with EXFO, and on today's 15 minutes or less, we'll be going over iOLM, Intelligent Optical Link Mapper. So what is iOLM? Well, over 30 years that EXFO has been in the industry, we've really been the leader in innovation of new technologies, and so iOLM is one of those. So really it takes you beyond an OTDR, or an optical time domain reflectometer. So iOLM is an OTDR-based application. So it does multiple acquisitions using multiple resolutions. Then it runs an algorithm on top of that and interprets the data. So one of the issues with an OTDR is if you can see a splice or an event at 30 miles, there's a very good chance you're not seeing anything at 30 feet. So you sacrifice resolution to test for distance. And the inverse is also true. So with an OTDR, if you could see something at 30 feet, there's probably a good chance you're not going to see something at 30 miles. So iOLM actually gets around this by doing multiple acquisitions, using multiple pulse width, and then interpreting that information and then presenting it to you in a manner that you can fully understand. So you don't have that graph that you usually see on an OTDR. You're really seeing almost like a network block diagram of all of the elements or events that are along that link. So it truly is a one-touch automated test suite. So once you have the configuration set, and we'll go through that, you literally just hit the start button and then let the iOLM do its acquisition and then show you the results. So I'm going to go ahead and do some testing now. So I have a network in front of me. I have an FTB1 platform with an FTB 730 OTDR. So OTDR iOLM, that is. And this particular piece of hardware, when it comes to the iOLM, a lot of the interface that I'm showing you on this particular platform is relevant for our other iOLM tests applications as well. So whether it's in the FTB 200, the FTB 500, the FTB 1, the FTB 2 Pro, the Max, there's a lot of different platforms that we support that supports iOLM. The interface will be the same. But in this particular training, I will be using the FTB 1 with the FTB 730 OTDR iOLM module. I also have here a network. So I have a network simulator. I have a launch box plugged into that. So we're going to go through an actual test, and I'll be able to manipulate the connectors a little bit so we can see some faults that are on the link itself, and then be able to analyze that using iOLM. So of course, the first thing you do is you clean and inspect your connector. So I did a different 15-minute or less training video talking about fiber cleaning. So we're not going to get into that, but it is critically important to understand that fiber cleanliness is really paramount when you're testing fiber optics with iOLM or an OTDR. So I'm going to go ahead and launch the application here. So I'll go ahead and click iOLM. So you see here on the display that we have OTDR or iOLM. So you can run both. In this particular training, of course, we're doing iOLM. So I'm going to go ahead and launch the iOLM module here. And so we'll let that fire up. So one of the first things we'll do is we'll get in there and configure it. And the great thing is once it's configured, then you really don't have to do anything but clean fibers and hit start, and then you're off and running. Okay, so iOLM is up and running now. So I have a launch box that I'm using, or a launch bag rather, that I'm using on this particular test. So this one is 150 meters. So I'm going to go ahead and reference out this launch cable. So I'm going to select 1310 and 1550. So I'm going to test both wavelengths. I'm going to select launch fiber and then hit measure. So this will measure my launch fiber for me. So I'll go ahead and hit OK. So make sure that I'm unplugged here. So it's going through and it's measuring the launch fiber. And if you have a receive cable, you can do the same thing. So here it's telling us that we have our launch cable, and then now that is referenced out. So I'm going to go ahead and inspect my, my connector again. And so basically here I have the end of the launch cable. I'm going to plug it into a bulkhead here so I can look at it. So I'm running the Connector Max software using the FIP 430B inspection probe. So it auto centers, auto focus, auto captures, and auto analyzes. And so we're looking at the end face here. It looks really good. So I'm going to go ahead and look at my network simulator as well. So I'm looking at the bulkhead side of that. And that looks really good as well. And so it is critically important to inspect and connect your fibers. So I'm going to go ahead and normal this back up. And then we'll be able to set up iOLM and run a test. So we'll go ahead and set up a configuration for iOLM. iOLM is heavily based on configurations. So it is critically important that you set your pass-fails for your connectors, your splices, and the other elements within your network. Because iOLM doesn't, when it does its analysis, it only knows if a connector is good or bad based on the thresholds that you set. So I'm going to go ahead and hit test configuration here. So over on the right side, we see test configuration. We have some pre-canned configurations that come with the unit. So if I were to hit select here, you'll see some of these pre-canned configurations. I like to use one of the existing ones and just modify it. So I'm going to go ahead and go into manage to manage the existing configurations. And since this is a point-to-point network, I am going to duplicate this, and I can name it whatever I'd like. I'm going to leave it as point-to-point 2 for now, and hit save. And then you'll see that it'll create an additional configuration that's called point-to-point 2. So I'm going to go ahead and highlight that and then modify it. And so this is where I can set all of my parameters for iOLM. So this first tab is the identifiers. So you can set custom identifiers if you'd like. Right now it's set up to increment up to 199. So if you have a 144 count fiber, you'll most certainly want to increase this number. I'm going to leave all these at default. Link definition, so this is where you define all the link information. If you need to create custom elements, this is where you can do that too. The scope of this training is really not going to cover that. That's a little bit more advanced than the intention of this training. Now, link pass fail, this is where you'll set your pass fails. And so I don't want to have any pass fail based on distance, but I do care about optical return loss. So I'm going to go ahead and just set it for any wavelength. I want my ORL for this particular span and this particular test, we'll say 32. And so this will, of course, vary depending on your needs. So that's what I have set for here. Link loss, so of course, if you have a predefined link budget, like for a GPON environment, this is where you'll set it. So this next tab is the element pass-fail, so your splices and your connectors. And so you'll see in here right now we have splice, connector, and connector reflection set in here. So you can set these all up to whatever parameters you have. So in this case, let's just set it for all parameters, 1550, 1310, whatever wavelengths I'm testing. So right now we have splice loss set at 0.3. I'm going to crank this down a bit, and I'm going to set it, say, for 0.15. So I'll set it for 0.15. This is my pass-fail threshold. For connectors, I like half a dB or better. So again, these thresholds or parameters will vary depending on your needs. So I'm going to go ahead and select that, and we're going to do half a dB for connectors, which is fairly typical. And then for reflection, we'll set it for -45. So again, these are just parameters that I'm setting. These will vary depending on your needs. So we'll go ahead and set it to that. I'm going to hit OK. And so now that's what this particular configuration is set up to do. Span optical return loss of 32 dB or better. And then we have 3 pass-fails set for connectors and splices. And so those are the parameters that iOLM will use when it does the analysis of the events or the elements on the trace. So I'm going to go ahead and close out of this. And then now that I have this set up, look at the bottom left here of the screen. It says default setup. So that's the configuration that's selected right now. So I'm going to go ahead and hit select. And I'm going to pick the one that we just edited, point-to-point 2, hit OK. So now my testing will be based on that configuration that I created. So down here at the very bottom, you see where it says point-to-point. And so the next thing I want to do is set up my user preferences. So if I go back to the home screen here, under user preferences, this is where I could set up my file naming, all my job identifiers and whatnot. And so over here under job ID, I can put a ticket number, whatever makes most sense to me. So, so I'll just say repair. I'll just call this repair for this for the training purposes here. And the company name, that is me, EXFO. So I'm not going to fill out the rest of these fields. You get the idea and the purpose of this. But it really is important that you fill this out as much as possible for the completeness of the report. Down at the very bottom, though, we have the identifiers for the actual file auto-naming, which is important. So right now I have the fiber ID set up as fiber. We're starting at fiber number 1 from CO1 to CO2. So this is how we'll identify the file name when we're doing autosaves. So if I go over to file name now, you'll see how this is selected. So you have different identifiers. So right now it's going to be repair, which is my job ID. underscore fiber1 CO1 CO2. So that's the file naming. And so you can check or add different parameters in here. So if you wanted to see what the wavelengths were, you can add that as well. I'm going to go ahead and remove that just for clarity's sake. So on this next tab, we have report. So we can save an OTDR graph along with the iOLM test report, which I like. So I went ahead and selected that. And of course, I wanted the diagnostics in there and the fiber sections. And so the type of report that we create is a PDF or an embedded HTML file. So I prefer the PDF. It has a nice, secure, professional look about it. So I'm going to go ahead and select that. I'm going to hit apply and OK. So from this point on, I'm actually ready to test. So I have my configuration loaded. I've nulled out my launch cables. I've cleaned my connectors. I've set my user preferences. Now I'm ready to go. So over on the left, I'm going to make sure that I'm testing the wavelengths that I care about. So in this particular example, I'm going to be testing 1310 and 1550. It's critically important that you test a long and a short wavelength to check for pinching or bending in the fiber. So once I have those wavelengths selected, quite honestly, all I do is hit start. So I'm going to go and hit start and let iOLM do its magic. So it's going to go in there, analyze the fiber, and then start testing. So at the very bottom right there, you'll see the indicator. Here down at the very bottom right, you see the test being run. So it's going through right now. And so you're actually watching iOLM think out loud. So as it uses different acquisitions and different pulse widths, you'll see different results show up on the screen. And instead of an OTDR graph, we have this block diagram, kind of a linear trace view with all the different elements. And again, you'll see how it changes in real time here as we adjust the different resolutions, you see different results. And so iOLM is going in there, it's shooting a trace at say 5 nanoseconds and 10 nanoseconds. It's cycling through the different resolutions and the different pulse width, analyzing the information, and then disregarding certain events. So it compares all the different acquisitions and then gives us the analysis based on that. And so now the test is done and we can interpret our information. So right in the very beginning here, you see it's interesting here. We can actually see the splice within my launch cable. That is really how cool iOLM is, that it's able to see that type of resolution. So at the end of this launch bag that I'm using here, at the end of this launch bag is a splice that connects this connector to the launch bag. And so that's what we're seeing here. We're actually seeing that splice, which is very, very close. It's about 4 meters or so. And so it's really close, but we're able to measure that. And of course, here's the end of our launch cable, because we referenced that out, right? So here's that 150, 160 meters that we referenced out. And then we'll see here that we actually have a little bit of a high loss at 1310, but it's really not that bad. We did a half a dB pass-fail. And so at 1550, it's 0.4 dB. So whether or not I address this is completely up to your maintenance standards. So, but if you see down here at the bottom, you can see the analysis. It tells us, so we have the red indicator that this element failed. The analysis tells us that this connector or bulkhead is damaged, dirty, or not well connected. Inspect and clean. So it's telling us to clean the connector and inspect it. So that's what the beauty of iOLM. It can see, it has really great resolution, but it also analyzes every single element that you have. And if it fails, it'll give you some ideas of what that problem might be. So as we're going through the network simulator here, we have a splice at 0.26 dB. We have a good splice out here. So I can just cycle through all the different elements here, all the way to the end. So this is 18 kilometers of fiber that we have up here. And so you'll see exactly how iOLM works and how innovative it is. And quite literally, it was one button push, and it gives us this information. So it's really, really quite cool. And so from this point on, you just save the data. So if I go ahead and hit save here, it'll save it as repair fiber 1, CO1 to CO2. Then I would move my jumper to the next port and be testing port number 2. So we're going to assume we're testing port number 2 here. And I'm going to do something. I'm going to create a pinch in the fiber. So I'm going to go ahead and pinch the fiber right at the launch. And I'm going to hit start here and let it do its acquisition. So I just want to show you what a macro bend or a pinch looks like. I think it's really cool to see on iOLM. So I'm pitching it right at about 150, 160 meters. So we'll let it run through its thing. So we're actually starting to see some information now. So I had that first connector selected from before, so it's still looking at that. So IOLM's running through. So it's shooting 1550 right now. And as soon as it shoots 1310, it's going to notice, hey, there's a pinch there. So now we're at 1310. And it's running through. And look at that. See that right there at the event 0? We're at 0 footage. That is the pinch that I put in the launch cable. So I literally put a pinch in the fiber right at the launch. So you can just barely see it here. And so there's the beep telling us the acquisition is complete. So I'm going to cycle back over to where that launch is at. So let me go ahead and go back there. And so right there at 0 footage, we have a macro bend. And so if you look down at the data down here, we can see that we have 2 dB of loss at 1310, 8 dB at 1550. I did a training video earlier on OTDR interpretation, and I talk about macro bending, and I show that. So I encourage you to watch that video. I'll provide some links for that as well at the end of this. But what we're seeing here is we have 8 dB of loss at 1550. If 1550 ever has more loss than 1310, then the problem is pinching. And so if I look down here, it'll tell us, inspect the fiber in this area and search for excessive bending or cable compression. That's the beauty of iOLM. So I'm going to go ahead and save that. And that's iOLM in a nutshell. Literally, it's just setting up a configuration and then running these tests and then cycling through it. Now that we have all of our acquisition done, I'm going to go ahead and generate a report. So with the last trace still loaded, I'm going to go ahead and go to File. You can see down here at the bottom where it says Report. I'm going to go ahead and hit Report. And this is where we can save our reports. And right now it's saving into this file structure here. So this is basically a Windows environment in the background here. I'm going to go ahead and hit Save. And that'll generate a PDF. So now you can transfer that information off of this platform and send it to whomever you'd like, and they don't have to have reporting software to view it. So I'm going to go ahead and show you what the report looks like. So I'm going to go ahead and switch screens here, go to the File Manager, and then I'll go to IOLM, and then we'll see the report that I saved here. I'll go and open that up, and that's just a PDF. So I know it's kind of hard to see on this screen here, so I'll kind of zoom into it. Let's maximize it here. And then you'll see what the report looks like here. So it's quite a professional looking report. So all the information that we put in there, the different test parameters, that OTDR graph that I asked it to embed is in there as well. It's a nice professional report with all the analysis in there as well. All the pass fails and the diagnostics, all within that report. I'd like to thank you very much for taking time out for this 15-minute or less series on iOLM Intelligent Optical Link Mapper. For additional information, please visit us at www.exfo.com. Thank you very much.